Hey peoples, in this video I'm going to show parts of the process involved with renovating this 1957 broadcast mixer. It's a Collins 212E desk, all tube circuitry, incredible sound, and of course it looks awesome as well. And as is very common with pieces like this now, it's electronically speaking, well, currently pretty much useless. Everything from the preamps to the power supply is non-functioning, needs renovation. It's been butchered so many times it's just not a happy bunny. A brief history for anyone interested to start with. What do I mean by a broadcast mixer? Well, simply put, it's an audio mixer but with routing and extra features that set it apart from an ordinary studio or PA kind of mixer. Most of these things are to facilitate mixing in a radio broadcast environment. So for instance, you'll find switches and relays that switch in and out the on-air lights or monitor paths for certain things, etc. So top left are all the switches to connect the inputs to the desk. Then we have switches for the monitor paths and the remote line switches, the output routing for the remote lines. And at the bottom are the routing switches and attenuators for the first, 4, and then 5 mixer lines, and then 6 and 7. VU meters, of course. You'll notice the one on the right has a gain reduction scale. That's because you can use a limiter module as an output amp. The customer doesn't have one for this, so we won't be using that feature. But then there's the other remote line switches, the switching for the VU meter input. That's for the one on the right. Then there's the master attenuators, a line output switch there at the top right, and remote line attenuators and switches at the bottom. As you can see, there's a bunch of leads attached, and they're all also helpfully marked with their destination rather than the source. So they're only of use to the guy that wrote them in the studio he wrote them for. Never mind, I'll soon get to the bottom of that, of course. So next step will be to open it up and see what we find on the inside. So you access the innards by dropping the front down like this. Of course, none of the modules are plugged in right now, that's why you don't see any tubes in there. So there's the input wiring there. Then here's the switching and attenuating parts, of course. And around about now, the more eagle-eyed amongst you will be starting to spot bodges and badly executed and ill-advised modifications to it, such as the rewiring of those two attenuators. You can see grey wire going to that looks out of place, and it is. But it gets worse because what they've actually done is wired output 2's line to those two attenuators to make what they thought, I think, was a stereo line. However, they've actually used the, you see there, they've used the, sort of gone in and out of the attenuator on 2 as well. But in case of the original output from the line 2, they've actually used the ground as ground, the cold pin of the balance signal as left, the hot pin of the balance signal as right, and tried to make that as a stereo output, which of course is a horrific idea because it'll be entirely, one is entirely out of phase with the other one. And that's not the only mistake. It's basically that output wiring is a mess, and if you could, I don't really have the time to show you exactly what's going on in a video like this, but if I went to the full extent of explaining what was going on, you'd probably be as confused as I was when I first opened it. Similarly with the output, the input stuff there on the screen, you can see, well, I can see quite a few mistakes and potential pitfalls with the way it's been done, but we'll get to that. And you can see there where stuff has been spliced in, those two leads that they've used to try to turn a balanced mono line into a stereo line. But in the worst way possible. And there we've got a permanent load resistor, which shouldn't be there, shouldn't have a load on it permanently. It should be switched in and out as necessary, i.e. when there's no other load present. Another a resistor there is wrong type and value, and both leads are just swinging around, asking to short out on something else. So I've started by removing all the bad output wiring, as you can see. I've left those bits in just for me to make it easier for me to test a couple of things later on. And next it'll be the turn of this rat's nest here. That's supposed to be the input wiring. This just says it all, really. This is the ground for the input on channel 1. Incredible workmanship. Right, all this cleared out. The next step is definitely going to be checking continuity throughout the desk to find out if and where, I would imagine where, there are broken wires and bad switches and loose things like the one I was just playing with there. So I'm just going to show a little bit of what that entails by checking the first part of the signal path through the first couple of channels. So you basically just need your meter on a continuity tester. And then starting with the obviously the point where the input comes in, testing whether it reaches that first switch. And you can see the meter changing there to 0 resistance. So you can see that there's a through channel, and then it's a matter of just popping through each one, testing its continuity through to the first point where you should find it, which in this case is, of course, those input switches at the top left. And then after that point, of course, with the switch engaged, it should then go from the switch to the preamp module, put the module to the attenuator, and then checking the path through the attenuator itself, which is why I'm reaching under there to adjust the pot on the front. And then you just repeat this process right through the desk, you know, to ascertain whether everything's functioning as it should be. And then when you know what's not, you can proceed to the next stage and get that part fixed first. These are the modules that plug into the desk. Those are the preamp ones. And then the two larger ones are the sort of output amps. There are no booster amps here at the moment, so I'm going to have to make or or well, I'm gonna have to make some. So this one has got a bad output transformer. That's we know that because it's written on a sticker on it. And same for this one, bad output, and the one next to it has got a bad input transformer. And then I think of the other ones, the other three have faults ranging from the filter caps to coupling caps and a couple of burnt out resistors and that kind of thing. So, you know, we'll have to work out what caused those faults, obviously. One of these power amps has output, apparently, or did at last check. The other one does not. We'll see whether that still is true or not. So this is the power amp that was supposedly fine. Let's turn it up and judge for ourselves there. Well, I can see several things straight off, but this one's really obvious. This cap here can attach its positive lead to pretty much everything around it fairly easily. I mean, that kind of thing is just lazy. You know, what effort does it really take to put a bit of heat shrink tubing around that leg just to make sure that that fault's not going to occur? It's really not that hard in something that's worth a few £1,000s. So this is one of the preamps. This one will need new filter caps, I'm sure, looking at that one. I think it's safe to say. And those old Sprague ones are almost certainly fine. I mean, this one doesn't look too bad in general. It'll need new cathode bypass caps. I don't know why I couldn't get that sentence out. And certainly new filter caps in there. Hopefully these Sprague ones will do what they almost always do and be entirely fine. Turns out that they weren't. So after testing one, you know, I've disattached one end in the ordinary way, tested through them at full voltage, and they didn't even get halfway. So next step is to replace the filter cap that I've removed. So here's what I'll do where possible. I've cut a piece of circuit board to match the shape of the original little Paxilin type board that was on the bottom of the cap. And I made it so that the pads show through, and then when you look from the top, there's just the Paxilin board with a couple of caps stuck to the top of it. This needs trimming up and finishing, of course. And as you can see, I'm part way through setting up a tag strip to help mount the cathode bypass caps. One of them will probably get mounted over there on the socket, and then one back here with the tag strip. These are going to be mounted, they're already on the tag strip with the wire that comes through that used to meet the cap that was the cathode bypass one as part of that multi cap that was there before. I just wanted to show you and stress how important it is to make sure you shine up that bit, any bit of the bus bar that you're going to attach something to, otherwise it won't solder on properly. So I thought I'd show you why some of these caps need to be replaced, and it sort of validates my instinct. This is the kind of cap tester you need if you want to test the actual working voltage that a capacitor can manage. It uses a Magic Eye tube display, so it actually gives a visual representation of the charging time of a cap and its upper limit, of course, when you get there. So switch it on, and what we're watching for is the Magic Eye, which will fall open like that whenever the capacitor is charged with the voltage that's been applied to it, to put it in the most simple way. So each time you turn the dial, you increase the voltage, and of course a bad cap takes too long or fails to open the eye at all. So I'll try and zoom in a bit there, get it in focus, and you can see the eye. And this is the bad one, of course, to start with. And you'll notice when I start to turn the dial that it'll close and then it'll open again. Very quick on 15 volts, and going up the scale still fairly quick. And now you can see we're only about 100 volts and it's starting to struggle already, and we're getting to 300 and 350 and it's really struggling. It's managed it, but I wouldn't be happy to use that even at 300 volts, and now it's on 400, remembering it was rated at 450. This is its attempt at trying to deal with 400 volts. So that was never gonna do its job sufficiently. And they're all as bad or worse. This is in fact one of the better ones, so that I could show you a longer process and it wasn't going to be over at 70 volts, you know. So this is a new cap of the same rating, a 450 volt cap. And again, I'll zoom in on the eye so you can see what one should behave like. And this is a Rubicon cap, which is one of my most trusted brands, as I'm sure it is with a lot of people. And no, I do not get anything free off them. Wish I did. So there you go. And as you can see, this I've started at a much higher scale to start with. And it's not immediate, but it's that's at 50 volts over its maximum rating, and now discharged. But that's how the first one would have behaved if we could have trusted it. I think you can see what's wrong with that cap there, a big solder burn on one side of it, so I can pretty much say that that's going to be knackered, but there we are. The filter caps, again, I sincerely doubt that that thing will do what it was supposed to be doing. So I've replaced that filter cap. And the cathode bypass caps again. Again, I'm hoping that these old capacitors, coupling caps, are going to be okay, but I'll test them and we'll see. But I just thought I'd show you what it looks like when I've done one of those from the top. Neat enough, I think. Now, I can't get the camera to see it perfectly well, but you can see the repairs they've attempted are not soldered to the bus bar well. That's because they didn't clean it first. So that'll all need to be done properly. And I'll have to check those coupling caps as well. They're not originals, but I'll just check them. Make sure that they're working as they should be before we trust them. Filter caps will almost certainly need replacing. Transformer needs rewiring as well, as that's quite poorly done, though I can't really zoom in with this camera very well. So same routine again with the checking a cap, lift the positive and test at increasing voltage. So that you can see whether or not the cap can actually stand the rated voltage in the circuit. Don't just test the capacitance, test its working capability, if you like. So it's the same thing again. I'm going to try and zoom in on the magic eye tube. And then these first voltages, it whizzes through them, but then you can see we're only at 50 volts and it's starting to struggle quite badly. And even when I took it back down and started again, it still didn't fare very well. So I'm just trying to get this camera to actually focus, but it's not playing ball, so I'm just gonna, you think you can see it well enough. So this is only on 300 volts now, on a cap that needs to be able to do at least 450. And it's really struggling. So first job, the connections to this bus bar. I've exposed the copper, I don't know how well you can see that, but so that I can redo the solder properly. You know, tin the bar first, and then a good solid connection with a decent bit of solder. And you can see it's far better. So I've done most of the work on this one. I just thought I'd show you this shining example of workmanship here. Again, whoever did this likes to play Russian roulette with fireworks displays, I think. And I spotted one more job on this one, these connections. When I pulled the insulating sleeve back, I saw that they were awful. I'm struggling to get the camera to show how bad they actually are, but they're all corroded and not very well attached, and the wire looks brittle around the edge of the contact, you know. So there we go, contacts cleaned, the wires neatened as much as possible, but of course I have to keep enough length in there, otherwise I've got to replace that couple of wires right the way through the module. There, now some signal might get through. And the delights continue with the output amp modules. Got a cap there that's the wrong value by a factor of 10, no less. Then there's this little abomination. What the hell is that? In these ones there's a few extra things to consider. I mean, look at this thing. That's, I think I showed that earlier, where the positive terminal of that thing can touch about 4 other contacts. So yeah, as I said, there are a few other things in these ones that are important to consider, such as the resistors that balance up the phase splitter and that kind of thing. So to start with, I've moved the components that bias the cathodes up away from where they were, up nearer the tube sockets, to give me some more space down there for when I rewire the parts of that are necessary. So even though I'm keeping some of the original components, I still disattach them from the bus, cleaned it up, re-tinned it and reattached them, because the connections were just awful that had been done in the past. So that's the first of those done. I couldn't get a board off this one, off the original cap, so it's just got the new one showing, but it's not too bad. It's, you know, functional, and it looks neat enough. And now it's time to tackle the one that was known to be non-functional. And again, I can safely assume this big multi-cap will be no good at all. And again, it's just generally a bit of a mess. Cheap components, badly soldered, no attempt to try and keep it neat so it's serviceable. I'm not going to show you all the detail of this one because it needs pretty much rewiring. There's so many faults within it. I just thought I'd show you this example of what happens when someone just clips old components away and rams a new one in and tags a new one on there. You end up with this horrible lumpy crappy pins with loads of pointless stubs attached. Now, I've actually removed the legs of the components that were tagged on there. These are just the old remnants that were wrapped around the pin socket there. So I'll obviously, as usual, remove all of those and clean the contact up. So there we are. The one on the right is the second one, which has been pretty much completely rewired. And I'm still to test the full audio functionality of the transformers in that one, because it was so bad to start with. I couldn't even test that without rigging them up out of circuit entirely. But the first one has now been tested with audio through it, etc. So I know that that one's done, at least. So this is the external power supply. Again, a drop down door on the front gives access to all the important stuff. The back there's the main chassis, which is connected to everything via the tags there. And then originally out to its destinations via those two Jones connectors on the left. The whole thing's very rickety, loose, missing screws, etc. Our current owner only needs to renovate and operate the audio functions of the desk. So I will be renovating the power supply and making a power cable to the mixer that powers everything needed. But I won't be making cables and such for the relay parts of it, because they won't be in use at this point. And there the chassis is out. So there's the mains transformer, filter caps, filter choke there, and there's test points for the voltage and a Jones connector again to connect to the wiring loom. Test points are there to set the voltage, because obviously it can accommodate between 1 and around 14 modules, and the difference in current is huge, so the power supply is necessarily variable. The big rectifier at the back is part of a circuit that this owner won't need either. So here's the underside of the power supply. There the rectifiers, of course, and the two big caps on the left there are the main filter caps, I should think. These two resistors there that are forming a little voltage divider that elevates the heater supply. And this is a pretty big design flaw. This big resistor gets warm as part of its ordinary working conditions in this circuit. So of course when you turn the chassis up the right way, it's no ventilation at all, and it's just been baking this wiring into the chassis for decades. So the customer doesn't need this secondary part of the power supply circuit, but I'm renovating it quickly anyway in case he should change his mind or sell it on. But I have moved its associated paraphernalia over here to make room for that big resistor, so it can radiate heat away through that hole where the old can capacitor used to be. And I've started rewiring the main section there, giving that resistor room to breathe. So the caps will just mount on that tag board there. If I'm careful about how I do it, they should, and careful with the iron at the bottom of them, because I'll have a very small gap to solder in underneath. But providing I do it carefully and slowly, they should manage to just clear the chassis underneath. And there we are. Just enough clearance from the bottom of the chassis for them all sitting there. A hot resistor away from everything else, and the other resistors there are double the necessary power rating. The ones, green ones there to the left, so they certainly won't be hot in ordinary use. There's a better view in better light. All cleaned up and raring to go. I've only used existing holes, etc. in the chassis, so if anyone ever wants to go to the trouble of using the original type, you know, have some custom multi-filter caps made and stick them in there, then they can. This has been done to a budget. Okay, so I've hooked up the power supply chassis so I can start to test the individual modules for basic operation up on the bench. Let me see if I can get a better angle. There we go. So the big insulated clips are from the mains, smaller cables carrying the B plus and heater supplies over to the modules, and a couple carrying the signal in and out. I have a meter reading the DC voltage there on the power supply. I'll try and get the scope screen in now to explain what I'm doing. So you're going to see at the bottom line of the scope screen, you're going to see a signal in, and then as we switch it on and bring it up, you're going to see a signal appear on the top, hopefully in phase. And there we are. Schematic says we should get around 40 decibels again. So I fed 100 millivolts in, and we're getting 10 volts out. I'll put the formula on the screen so you can see that why that means 40 decibels, but it's about right. And this is just me checking the feedback winding to see if I'm getting a clean wave there to attenuate the first stage smoothly, and we are. Also making sure that it's you know, roughly the right size and out of phase. So now I'm going to reassemble the power supply properly. I've checked all the other modules in the same way as that first one. There's a few things to attend to before I put the chassis back in. Number one is this awful cable. It should at least have the heater wires twisted. That's their AC, and they'll be running across a studio. And it needs to be made neater and held together better, and it'd also be a plus if we didn't have to rely on masking tape as a way of knowing what plugs into what. Also, I think a longer mains plug cable would probably be beneficial. And as I said before, the whole thing's rickety. It's missing bolts, and parts of it are bent slightly out of shape, so I'll have to try and do something about that. So I've made a simple plywood case as well. Although I haven't charged the customer for it, but I just couldn't bear to send this power supply back, you know, with its mass flapping around in the wind in the back of a van or whatever, so thought it'd be a bit safer like this. So as you can see, I've corrected all the wiring faults, bad modifications, incorrect components. Also done a dozen or so dry solder joints on there, and the mixer chassis is ready for its new input and output wiring. This is the cable to bring the heater and B plus lines into the mixer from the power supply. I'm using a good solid connector there that can only be connected in one way, so a far better method than before. And twisted heater wires. And there we go, that's the connector connected together now. Good and sturdy. And then a much neater cabling arrangement into the power supply box. And then runs across, up, through the side of the main body of the mixer. And there inside you can see all the output line and monitor line wiring redone neatly. Nice and secure, travelling immediately away from everything else. And then up across the top and out the side. And on the left there we've got at least twice as many input lines wired in than before, and it still looks neater and more serviceable because some effort's been made. The signal wiring in and out is almost all on these multi-pin connectors now, and they're going to land in clearly marked custom patch bays, as you'll see. And there's a couple of the main outs are still on 2 jacks into the patch bay they're going to go into. I just thought I'd show you one of the inside of one of those connectors. As you can see, I made it easy for myself by only using every other pin, plus the amount of wire you can get in and out of the connector housing is limited. I'm just going to check that it works at the simplest level to start with, so 1 channel, 1 booster, 1 output amp, and keeping it simple, and then adding complexity as you go makes potential troubleshooting a lot easier. So this is the desktop patch bay being made, and that'll bring the output lines and tape returns in and out of the mixer, and the monitor line. I won't bother to explain the signal paths as they're configured in the most convenient way for the owner, but there are several ways that it could have been done. As this one's going to be seen in his studio, I've made it look like it fits in with the decor to some extent. So I've put it in an old case. That was a new old stock one that I had. So old but never used, in other words. I've used Letraset and sealed it off with polyurethane, a thin coat, just to make it fit in with some of the other things that are already in his studio. And this is the input one. Also includes a few throughputs for headphones in the studio it's destined for. But for the most part there you can see there's mic lines and line input lines going to the multi-pin connectors that take it up to the desk. So rather than testing this thing on a dull way here on the bench, I'm going to hand you over to Pat Rayford at Retro Rose Studios in Norfolk, which is where this mixer is destined to be. I've asked him to send me a clip of the mixer in use when it gets there. He's got an awesome vintage style recording studio, So you're going to hear a clip from a band called the Midnight Crawlers, who were the first to record through this mixer when it was finished. I think you'll be hearing the tape being played back rather than the recording session part, but you'll still see the mixer in use in a far more interesting way than if I was to just say 1-2 on the bench. So I'll hand you over now.
Now if you got a man and it can't be true,
listen and I'll tell you just exactly what to do. Fan it,
fan it,
just fan it,
fan it.
fan it, cool it, honey, till the cows come home.
You gotta love him in the morning, in the afternoon.
But you ain't really loving until you love beneath the moon. So fan it,
Fan it,
just fan it,
fan it.
fan it, cool it, honey, till the cows come home.
Now if he likes loving and he wants to stay at home,
Just keep on turtle doveing, leaving well enough alone, and fan it,
fan it,
just fan it,
fan it.
fan it, cool it, honey, till the cows come home.
Now if he man's mean and he don't like your style,
Don't worry about him, let him go hog wild and fan it,
fan it,
just fan it,
fan it.
fan it, cool it, honey, till the cows come home.
As usual, thanks for watching. Well done if you made it to the end. It was a long one. If you liked it, then like it. And if you want to see any more similar videos, then subscribe.